asymptote on number 1? Second one. Y equals 0. And the last one. Good. Questions? It just said horizontal. So, I didn't have to. But you're right, there is a slant asymptote. Okay. What question did you ask yourself to find those answers? As x gets really, really big, what does y do, right? Isn't that what you're asking yourself? Does that not sound like a limit? As x gets really, really big, as x approaches infinity, what does y approach, right? So I would argue that we just did the limit as x approaches infinity of x squared minus 5x plus 2 over x squared plus x cubed. And we decided that that limit was 0. Because we plug in a really big number, and we would end up dividing by, really, right? Pretty much. So that's what we're learning how to do today. Whoops. So, yeah, I got a video for you later. There are 2 different cases of limits at infinity. And that's what we're going to spend the next 2 days talking on. Those of you gone with beta tomorrow we're going to focus on limits as x approaches a vertical asymptote, and so the answer to the limit will be infinity or negative infinity. Raise your hand if you're going to be gone tomorrow. Make sure you get that worksheet from me before you leave. To me, tomorrow is a little bit easier discussion than today, but neither one's particularly hard. Yeah, watch the video and you will be fine. Limits as x approaches infinity means that x is getting bigger and bigger. The idea is going to be very similar to horizontal asymptotes. Now, of course, we'll have some functions that aren't rational functions, so we'll have to think about how those work. But if we do have a rational function, we have some rules that we can follow. Limits that equal infinity, or negative infinity, are ones where we're approaching a vertical asymptote. These limits don't actually exist. So kind of little mental note, those limits technically don't exist, but we're going to go ahead and give it a direction for just mental note which way it approaches. Technically, a limit can't equal infinity. We talked about the technicalness of that because it can't get in a box. Y'all remember us talking about that. But we still will want to know from the left and the right whether we're approaching infinity or negative infinity. So the limit as x approaches 0 from the right here would be positive infinity, and the limit as x approaches 0 from the left would be negative infinity. And that's what our focus will be tomorrow. So limits that equal infinity happen at vertical asymptotes. Any questions about that so far?
Is it forward, vertical?
No, horizontal.
Michael, I didn't ask for your negative input.
This is just for fun.
It was I'm gonna miss you.
What's the biggest number you can think of?
A trillion, billion, zillion.
That's pretty big. How about you?
10.
Okay. How about you?
Infinity.
Can you top that?
Infinity and 1.
Actually, we were looking for infinity plus infinity. Sorry.
What about infinity times infinity? Oh.
It's not complicated. Bigger is better. And AT&T has the nation's largest.
Okay, so we're going to be talking about infinity today. All right, so the first thing we're going to look at is limits where x approaches infinity or horizontal asymptotes. That's what we're going to focus on today. Tomorrow we will do vertical asymptotes. If I have time at the end of the day, I'll go ahead and pull that up for the 4 of you who won't be here tomorrow and give you a quick, short, sweet, if we have time. But first we're going to focus on limits as x approaches infinity. We are going to use our horizontal asymptote rules as long as we can. Now there will be times we'll have to think without them, but as long as we can, we're going to keep those rules in mind because they're going to make our life easier. So, as x gets really, really big, we talked about this, and you probably wondered why I was giving you so much information. I am. It's. Thank you, though. I do, and sometimes I do forget. This is probably a little bit more than you needed to know when I first taught it to you, but I remember me talking about plugging in really, really big x's and how these numbers didn't matter. You remember all that discussion. Right? This was why we had all of that discussion. So the leading powers take over. 10x squared divided by 2x squared is 5. So as x approaches infinity, y approaches 5. Levels off to a horizontal asymptote. As x gets really big on this one,
0.
Those don't matter. The bottom's bigger. I divide by really big numbers,
0.
and I get 0. Now, something to mental note that is not always, some of you just know, and then others of you might not. If we are not dealing with a polynomial on top and bottom, say we're dealing with an e to the x. Question, does e to the x grow faster or slower than a polynomial? Faster. E to the x beats everything, right? It grows faster than anything else, right? Natural log or logarithms grow slower than just about anything else, and then polynomials fall in the middle. So just mental note, things that aren't polynomials, how fast they grow. If the power on top is bigger, this is a case we haven't talked about because on the bell ringer you said no horizontal asymptote. We are going to go ahead and put an answer on this limit, but it's either going to be infinity or negative infinity. Would you agree with that? It's either approaching positive infinity or negative infinity, and we are going to answer with one of those two things. To figure out which one, I'm going to simplify this.
It's infinity.
10 divided by 2 is 5, and then x. Does everyone agree that simplifies to 5x? And then I'm going to do the limit as x approaches infinity of 5x, which is positive infinity. 5 times infinity, yes.
Whoa!
Yeah, I just simplified the highest power on top and bottom.
You can only do that if it's 1x, right?
No, you can actually do this anytime. You can always simplify and then see what would happen if you plugged it in. Okay, if this had been approaching negative infinity, would this change? What would we be approaching? Negative infinity. Kind of an end behavior question, isn't it? Try these.
You do them right.
I hope a lot of them you can. Probably not all of them, but I hope a lot of them you can. Okay, have we figured out number 1? Okay, as x gets really, really big, leading powers take over, negative 1/4. Any questions? Would it have mattered if we had been approaching negative infinity? No, it still would have been negative 1/4, right?
Yeah.
Either way. That's
Same time.
okay. This one, as x approaches negative infinity, y 0, but it's negative. We're dividing by a big negative number. Who cares? We're still going to 0, right? Okay, this one's tough.
Exact same. Radical 3 over 1.
Very good. Radical 3. Why?
Because it's just radical 1, which is
Okay,
1.
those two take over. They do have the same power, so we expect to approach a constant. But does the radical disappear? No, so what is the constant? And Drew said it perfectly. He said it's radical 3 over radical 1, but radical 1 is just 1, so...
So it could be 3 to the power of 1.
It could be 3 to the 1/2, that's right.
Thank you, Michael.
Any questions about that one? That one was hard. I want to sit here for a second. Anyone have a question about it? Does it make sense? You like that? Okay, let's look at the next one. Okay, let's look at the next one. X is approaching negative infinity. Which case is this falling into?
Ratio.
Powers are the same, right? So we've got a ratio. Is the answer 3?
No,
Why not?
it's negative.
Neither one. The power of 3. So
Oh,
technically I would have to FOIL this out and then multiply by 3x minus 1,000 again. However, if these are the only two things that matter, right? Then why don't I just cube those things, right? The rest aren't going to matter anymore. Okay, 27 sounds better to me.
times 3.
27x cubed over x cubed. Remember, I know there's more stuff out here. I just don't care. And what do I get? 27. Why not negative?
Because it doesn't matter. Because negative goes to negative.
Right, a negative divided by a negative gives us a positive. So, just 27.
For the smart kids.
Okay, let's do some more. Pretty much, yeah.
Can we go ahead and do tomorrow's lesson?
I may do a little bit for the people who aren't going to be here. I have it pulled up in case I decide to. Horizontal asymptote stuff, yeah. So this is the edition of the day, yes. I know, it feels, after the last 3 weeks, it feels like we've really slowed down, doesn't it? I know, right? It's nice, isn't it?
30.
So I was trying to find a way to make you like calculus. Did I succeed?
Well, so far.
Oh, you're right.
You bring cookies.
We will do it.
For sure.
Okay, we're taking turns.
Let's just have a party.
We will do that on the Friday before spring break. Pie day. It's not really pie day, but we'll pretend it is. Yes, do what? The Friday before spring break. We will celebrate pie day.
It's not the 18th, spring Friday. March.
Yeah, I know, but we always pretend March the 14th falls the Friday before spring break because it's just nicer that day. we just pretend. Okay, let's go. Quiet, quiet. Okay, let's look at this one. X is approaching negative infinity. So if you couldn't tell what that said, it does say X is approaching negative infinity. What does this reduce to? 95x. And so if I do the limit as X approaches negative infinity, negative infinity. Any questions? Okay, top right, X approaching positive infinity. Quiet. Shh. What is Y approaching as X approaches positive? Okay, now there wasn't a bottom. How do you know that's infinity? Okay, it's over 1 or x to the 0 power. So the top's bigger. I know I'm either approaching positive or negative infinity. Remember, the -4 doesn't matter. Bill Gates doesn't care if he spends $4 somewhere, right? It's not going to affect his bank account. So 2 times infinity is still infinity, right? Weird question. The limit as x approaches infinity of sine of x. It might be helpful to have a picture of that in your brain. What is sine of x doing?
It's infinity. Does not exist.
I agree with Bryce. Why does it not exist? It's not approaching one value as x approaches infinity. It goes to 1, -1, 0, 1, -1, 0. Right? It's always changing, so that limit does not exist. What?
Negative infinity.
Okay.
Negative.
Why negative infinity?
Negative. 2 times negative.
2 times negative infinity. Still going to give me a negative infinity. How are we doing on infinity limits so far? Good?
Infinity.
What about x squared?
Infinity.
I agree. Why infinity?
Because if you did x
Square it.
What if I were approaching negative infinity?
It'd still be infinity.
It'd still be positive infinity, wouldn't it?
oh yeah.
Because I'd square a negative, which would make it positive. So, right, because, and look at the graph. What does it do on both ends? It goes positive infinity. Makes sense, right?
Infinity.
Okay. Uh-oh.
Is that e to the
X approaches infinity of x squared times e to the negative x. Don't answer out loud. Think about it.
I already thought about it.
Well, then hold that thought for just a moment.
why is that e to the negative x?
It is x squared e to the negative x as x approaches infinity. Limit is x approaches infinity of e to the x.
No, it's 0.
This one.
Yeah.
So e to a big number. What's even e to a small number? E is 2.7-ish. It's a number. And what happens when you raise numbers to powers? They get big.
So, can I answer?
Okay, what do you think the answer is?
Infinity. 0.
Okay, I get negative infinity, 0. Any other guesses?
Guess.
1 does not exist. Okay, we have a problem. Why it's a problem is if we plug in infinity, we get infinity
Just forget that X.
times 0. Why times 0?
That's so close to 0.
Because anything to negative power, what does that do to it?
Well,
Oh, bad.
Okay, in this format, I don't know the answer. Infinity times 0 is kind of like 0 over 0. It's what we would call an indeterminate form. I don't know what infinity times 0 is going to give me. But if I rewrite it this way, I do know what that's going to give me because which one grows faster? E to the x. And if the bottom's growing faster, I get 0. But that one was a hard one.
Yeah.
Oh my god, no. I thought about it.
Any questions about that one?
Come on,
next lesson.
Not yet.
Lesson.
Got some AP problems. Okay, real AP problems.
Next.
Okay, I want you to try all 3 of them. they will take some thought. The top one's easy, which should be encouraging about AP. The bottom two, not so much. If I make it bigger, you won't be able to see the answers. It's n approaches infinity of 3n cubed minus 5n over n cubed minus 2n squared plus 1. I copied that from an AP problem.
Yeah.
That kid out there.
Maybe. No.
Sure that neat.
Do it. Come on in, dude. You don't have to grab it.
Dude.
Oh.
That's right. Some guys were
Okay, let's get started. And Austin, grab one of these and pass them around. Your homework is coming around as well. Okay, so these are important because these are tough. Well, some of them. Is number one tough? No. This is a real AP problem on the real AP exam one time. So, three, they're right. Look at you. Okay. These are a little more complicated, and these are actually pulled from a prep book, and then I modified it to show you two different ways and why they were doing, where they got their other answers from. And this one's a tough one.
That's easy.
Okay. This one here,
It's not.
the limit as n approaches infinity. Well, as n approaches infinity, that negative exponent puts the e on the bottom of that piece. Now, how many of you tried to move it up to be with the 4?
Not me.
Why can you not do that? Because there's a plus in between, right? So, to rewrite this one, I need to write it as 3 plus 5 over e to the 2n. Okay. Then, as n approaches infinity, would you all agree this little piece goes to 0? That little guy? Turns out, the biggest exponent here is the 0 exponent, isn't it? Because that negative exponent is a small exponent, right? So the biggest exponent is the same on top and bottom, the 4 and the 3, and you get 4/3.
Why'd you cancel out the
So I rewrote it, and then I thought about what would happen if I plug in really big numbers. As I plug in really big numbers, 5 over e to the n gets close to 0. But what happens to e as I plug in really big numbers? It gets huge, and I divide by a huge number, which gets me a tiny number. So that little piece went to 0, which meant the only thing that was left was the 4/3. Okay, let's look at the other one. Does it behave differently? Yes, because what happens to a negative times a negative? Positive. So this one, this thing gets really big, right? So I'm dividing by a huge number, which gives me 0. Right?
So why can't you just do that on the other Smaller.
This thing is going to 0. This well, if that goes to 0, 3 plus 0 is 3. And so you get 4/3.
Yeah.
And we need the home.
Okay, I don't have time to do any conversations about if you